Welcome to a second video on partial fraction decomposition. In this video we'll take a look at having quadratic factors. This video does assume you've already watched part 1, so we're going to go ahead and go quickly into the examples after a quick review. Before we perform partial fraction decomposition, if the degree of the numerator is greater than the degree of the denominator, we do need to divide the denominator into the numerator to obtain a polynomial and a rational function where the numerator is less than the degree of the denominator. Once we have the rational function in the correct form, we're going to factor the denominator completely into linear and quadratic factors. If it's a linear factor, we'll have single variables in the numerators, and if a linear factor is repeated, we do have to write an extra fraction for each repeated linear factor. For quadratic factors, we'll have a linear numerator in the form of bx plus c, and again, if the factor is repeated, we do have to have additional fractions for each repeated factor with a different numerator. Once we have the partial fractions, we're going to multiply each fraction by the LCD and solve the resulting basic equation. The process is a little more involved with quadratic factors. We have to expand the basic equation and then combine like terms based on the power of x to set up and solve a system of equations. Let's go and take a look at our first example. To save a little bit of time, the denominator is already in factored form, and this does not factor because there's no factors of positive 3 that add to negative 2. So we have a linear factor and a quadratic factor. So for the linear factor, we'll have a over x minus 2 plus, for the quadratic factor, we'll have bx plus c all over x squared minus 2x plus 3. Now we'll multiply every fraction by the LCD, which is x minus 2 times x squared minus 2x plus 3. Notice on the left side, both factors simplify out. We're left with 7x squared minus 13x plus 13 must equal, here only the factor of x minus 2 simplifies out. So we have a times x squared minus 2x plus 3 plus, here the quadratic factor simplifies out. So we have bx plus c times x minus 2. Now because we have a quadratic factor, we are going to have to multiply all this out. But before we do that, if we use the 0 of the linear factor, we should be able to determine either a, b, or c. Let's go ahead and try that. So if x equals 2, we sub a 2 in here, we'd have 4 times 7, that's 28, minus 26 plus 13, that'll give us 15, equals, again, if a is 2, we'd have 4 minus 4 plus 3, that'll give us 3 times a. And then if x is 2, this would be 0 times anything would still be 0. So we have 15 equals 3a, so we know that a is equal to 5. But to determine the values of b and c, we are going to have to multiply all this out and then collect the like terms based upon the power of x. So we're going to have 7x squared minus 13x plus 13 equals ax squared minus 2ax plus 3a plus bx squared minus 2bx plus cx and then minus 2c. Now we're going to combine the like terms based on the power of x on the right side. So here are the x squared terms, here are the x terms, and here are the constant terms. So we'll have a plus b x squared plus negative 2a minus 2b plus c times x, and then for the constant terms we just have 3a minus 2c. Now we're going to match up the coefficients, meaning a plus b must equal 7, all of this must equal negative 13, and all of this must equal positive 13. Let's start with a plus b must equal 7. But remember, we already found that a was equal to 5, so if a is 5, we know that b is going to equal 2. So now we just need to find c. Let's take a look at the constant expression here. We know that 3a minus 2c must equal 13. But again, we know that a is equal to 5, so this would be 15 minus 2c equals 13. If we subtract 15 on both sides, we'll have negative 2c equals negative 2. So now we know that c is equal to positive 1. So now we know the values of a, b, and c. So now we can rewrite this rational expression as a sum of these two fractions. So this rational expression can be rewritten as a over x minus 2, which is 5 over x minus 2, plus bx plus c over x squared minus 2x plus 3. So we'd have 2x plus 1 over x squared minus 2x plus 3. So this is the partial fraction decomposition of this given rational expression. Let's see if we have time for one more. The degree of the numerator is less than the degree of the denominator. So let's go ahead and factor the denominator. This will have two quadratic factors. The factors of 2 that add to 3, that would be plus 2 and plus 1. And since these are quadratic factors, the first one will be ax plus b over x squared plus 2. And the second fraction will be cx plus d all over x squared plus 1. Now we're going to multiply every fraction by the LCD, which would be the quantity x squared plus 2 times the quantity x squared plus 1. On the left side, these factors would simplify out. We'd be left with x cubed plus x squared plus x plus 2 must equal. Here, only the factor of x squared plus 2 would simplify out. So we'd have ax plus b times the quantity x squared plus 1. And on this fraction, the x plus 1 would simplify out. So we'd have cx plus d times x squared plus 2. Since we don't have any linear factors here, we are going to have to multiply all this out on the right side and then combine the like terms. So we'd have ax cubed plus ax plus bx squared plus b plus cx cubed plus 2cx plus dx squared and then plus 2d. Let's go ahead and color code the like terms. So let's go ahead and combine our like terms now in terms of the powers of x. So we'd have a plus cx cubed plus b plus dx squared plus a plus 2cx, and then lastly plus b plus 2d. Let's go ahead and include the coefficients here. We have 1, 1, 1, and then 2. So we have a plus c equals 1, b plus d equals 1, a plus 2c equals 1, and b plus 2d equals 2. Let's go ahead and call this equation 1, equation 2, equation 3, and equation 4. Let's go ahead and take equation 3 and subtract equation 1. So we'd have a minus a, that would be 0. 2c minus c would be c. And then 1 minus 1 would be 0. So c is 0. Well, next, if c is 0, then a plus 0 must equal 1. So a is equal to 1. Now let's take a look at equation 4 and equation 2. Let's take equation 4 and subtract equation 2. So we'd have b minus b, that would be 0. 2d minus d, that would be d. And then 2 minus 1 would be 1. So d is equal to 1. Now looking at equation 2, if d is equal to 1, b must equal 0. So we have all the information we need. We just need to fill in the values of a, b, c, and d into these fractions here. Let's go ahead and do that on the next screen. Okay, so here's the original equation that we had. Here are the fractions we want to find. And now we have the values of a, b, c, and d. So this rational expression is equal to ax plus b over x squared plus 2. Well, a is 1 and b is 0, so we'd have x over x squared plus 2 plus, and then for this fraction, c is 0 and d is 1, so we'd have 1 over x squared plus 1. And this would be the partial fraction decomposition of this given rational expression. Okay, I hope you found this second video helpful. Next, we'll take a look at combining this with integrating rational functions. Thank you for watching.